Hello, good evening, all of you. My name is P. Mohammad Arshad Basha. I am studying in CSMB section in SRIT. Today, my topic is drift current physics. Introduction to drift current physics. Drift current refers to the flow of charge carriers in material due to electronic field. It plays a carrier role in the operations of electronic devices such as transistors and diodes.
Oh,
Drift current is distance for diffusion current, which is driven by concentration gradients. This is the voltage of drift current. The direction of drift current is determined by the polarity of electric field applied to the materials. Charge carrier experience collision with latent ions, impurities, and other carriers affecting the drift velocity. Drift velocity. Drift velocity is the average velocity of charge carriers in response to the applied electric field. It is directly proportional to the electric field strength and inversely proportional to the effective mass of the charge carriers. Drift velocity is often much lower than the thermal velocity of charge carrier due to the scattering machines. Direction of electric field is negative ion. Average average rate velocity is positive ion. Drift current density. Drift current density is amount of charge transport per unit area per unit time due to the drift motion. It is given by the product of charge carrier density, charge of carriers, and drift velocity. Drift current density is a key parameter in understanding the electric behavior of semiconductors. Current and drift velocity. Definition. Current is a measurement of amount of charges passing by the per unit of time. It is a scalar. External relation. The external relation relate to the mobility of charge carriers to their diffusion coefficient in a material. It provides insight into the relationship between different diffusion current in semiconductors. The intention relation of fundamental concept within understanding charge transport phenomena. Carrier mobility. Carrier mobility is measure of how quickly charges carrier responds to the applied electric field. It is influenced by factors such as sectoring machines, temperature, and doping concentration. Carrier mobility is a key parameter in determining the performance of semiconductor devices. Using of-effect measurement to determine mobility, carrier type, and carrier concentration. Relationship between drift and drift current. In a semiconductor under applied electric field, drift current arises due to the movement of charges carrier and central drift current. The magnitude of drift current is dependent in charges carrier density, charge and drift velocity. Understanding the relationship between drift current and drift velocity is an device designing optimization. Impact of temperature on drift current. Temperature affect the sacrificing machines experienced by charge carriers. Influence their drift velocity and mobility. Higher temperature can lead to increased carrier scratching, reducing the over drift current and semiconductor. Temperature also affect incident carrier concentration, which plays a role in determining drift current behavior. Application of drift current physics. Drift current physics is essential for the design and operation of semiconductor devices such as transistor, diode, and solar cell. Understanding drift current enable energies of optimize the device performance and efficiency. Research in drift current physics continues to drive advancement of semiconductor technology. Conclusion. Drift current physics plays a circular role in the behavior of charge carriers in semiconductor under an applied electric field. By studying drift current phenomena, researchers and engineering can improve the performance of electronic devices. Continue research in drift current physics is a virtue of the development of future semiconductor technology.